At the end of class in stats on Monday, we dove into conditional probability. So here we have a problem. Should look familiar. We had the same exact table a little bit ago in the last handout. And we changed the questions. So without looking at the formula or hearing a clear explanation from me, I think you can figure this out. If I choose a male, that means I have a male standing in front of me. I am only looking at these values. What are the chances that that male has pierced ears? So when you say if it's a male, now we're talking about out of 90. Let me write that better. And there are 19 people with pierced ears. And that's it. That's conditional probability. So the if limits your denominator, limits denominator to 90. And then you go out of that column or row the number you're interested in, and that's 19. And that's it. There is a formula for this, but you can do this in your head with a table. So let's try it again. If we're looking at someone with pierced ears, how many have pierced ears? Looks like 103 people have pierced ears. So just look at the purple circle. So I'm looking at the purple people there, 103. Probability that they have probability that they are male, there are 19 of them. So one more time, the if limits your denominator. I said that funny. Your denominator, put the emphasis on some other syllable, to 103 in this case. All right. You can write that as a decimal if you want. So I've been writing them as decimals. You can write that one as 1845 and the top one as 21 1, repeating 1, and that works for me. Some people struggle and they have to have a formula. So this formula down, or let's see, next slide, is on your formula chart. So they have this typed on your formula chart. And you read that probability of A given B. So that vertical line is read as given. Given that B happened, you almost have to read it backwards. Given that B has happened, what is the probability of A? So in this scenario, pierced given male, we were talking about pierced intersect male over all the males, which we already figured out was 19 out of 90. That second one is male and pierced, which, by the way, the order does not matter in the and statement. But in the given statement, it definitely changes the denominator. So what I just now said, in the and statement, A and B is the same as B and A. Those are interchangeable. So that's why up here in the numerator I said that. Because these look different, but they are the same. Both are 19. All right. I hope that makes sense. We'll practice it more in the next lesson. Bye, y'all.